Have you ever had two, maybe three different problems that seem totally separate, but you know there's got to be one single answer that solves them all? Well, in algebra, we do that all the time. Today, we are building your algebraic toolkit. We're going to master three super powerful methods for solving systems of linear equations. By the end of this, you'll be an algebraic problem-solving pro.
So, here's the roadmap. First, we'll get a handle on what linear systems even are. Then we'll dive into our three main tools: substitution, elimination, and graphing. And to wrap it all up, we're going to see how these tools work on some actual real-world problems. Let's jump in.
Okay, first things first. Before we can start solving, we need to know what we're actually looking for. When you hear a system of linear equations, I want you to think of two things: lines on a graph. Our job? It's like a treasure hunt. We are looking for that one single point, that X that marks the spot where those lines cross.
So, to put it officially, a system of linear equations is just two or more lines that share the same variables, like x and y. And the solution we're hunting for is that one single coordinate, that one x, y point that lives on all the lines at the same time. It's the one place where they all agree.
Now here's a cool thing. When you have two lines, there are really only three ways their story can end. They can cross at exactly one spot. That gives us one solution. They could be parallel, right? Just running alongside each other forever, but never ever touching. That's no solution. Or, plot twist, they could secretly be the exact same line, just written differently. In that case, they share every single point, giving us infinitely many solutions.
All right, let's open up that toolkit. First up is a really clever method called substitution. This is your absolute best friend when one of the equations has already done some of the work for you. Like when it's screaming, hey, y equals this.
The whole idea here is pretty slick. You take one equation and you isolate a variable. Get y all by itself, for example. Then you take that whole expression that y equals and you plug it into the other equation. What happens? All of a sudden, you've only got one variable left, x, and you can solve for it. Once you have x, you just pop it back into the first equation to find y. It's a chain reaction.
Okay, let's see it in action. Look at this system. That first equation, y equals 3x plus 2, it's basically perfect for substitution. Step 1 is already done for us. It's telling us exactly what y is.
So since we know y is the same thing as 3x plus 2, we can just swap it into the second equation. See that? Instead of 2x plus y, we now have 2x plus 3x plus 2. And just like that, the y is gone and we've got an equation with only x's.
And now, we just do some simple algebra. Combine the 2x and 3x to get 5x, subtract 2 from both sides, which leaves us with 5x equals 12, and for the final move, divide by 5, and we get our answer, x equals 12 over 5.
We are so close. We have x, but we still need y. So we take that x value, 12 over 5, and plug it right back into our easy equation, the first one. A little multiplication, a little addition, and we find out y is 46 over 5. And there it is, our solution. That's the exact point where these two lines meet.
Okay, tool number 2. This is a real powerhouse method called elimination. This technique is fantastic when your equations are lined up nice and neat, with all the x's, y's, and numbers stacked right on top of each other. The goal of elimination is to make one of the variables disappear. Seriously, we're going to add or subtract the two equations together in a way that makes either the x's or the y's completely cancel out. Once one is gone, solving for the other is a piece of cake. Then we just plug that answer back in to find the one we eliminated.
Check this one out. You see how the first equation has a 3x and the second one has a negative 3x? They're perfect opposites. They are just screaming to be added together and eliminated.
And this is where the magic happens. We just add the two equations, top to bottom. The 3x and the negative 3x, they cancel out to 0. Gone! The 2y plus y gives us 3y, and 16 plus 1 is 17. We're left with 3y equals 17. A quick division, and bam, we know y is 17 over 3.
So to wrap this up, we take our new y value and plug it into either of the original equations. Doesn't matter which one. A little bit of algebra later, and we find that x equals 14 over 9. And that's it. We found our coordinate, our solution.
All right, on to our last tool, and this one's the most visual of the bunch, solving by graphing. This method is all about taking the numbers and letters and turning them into a picture so you can literally see the answer.
The process here is actually pretty straightforward. You just need to get both of your equations into that format you probably remember, y equals mx plus b. Once you've done that, you just draw the lines on a graph. The spot where they cross, that's your answer. It's that simple.
So let's look at this system here. For our first line, we have a slope of 2 and a y-intercept of -1. Easy enough to draw. For the second line, the slope is -1 and the y-intercept is up at 5. We have everything we need to plot these two lines.
And if you were to draw these on a piece of graph paper, what would you see? You'd see them cross at one specific spot. That single point of intersection, the only place they have in common, is our solution, the point 2, 3.
Okay, so this is where it all comes together. All these methods, all this algebra, it's not just for math homework. These are genuinely powerful tools for solving actual real-world problems.
I mean, check these out. Trying to figure out how many adult and child movie tickets you sold? You can set up two equations and use substitution to find the exact number. Wondering how many chickens and goats are on a farm? Set up one equation for the number of heads and another for the number of legs. That's a perfect setup for elimination. Or what about comparing two different gym memberships to see which is a better deal? Well, you can graph them as two separate lines and find the exact point where one becomes cheaper than the other.
And there you have it. Substitution, elimination, and graphing. They are three totally different tools for sure, but they all help us do the same thing. Find that one single point where different paths, different stories all cross.
So now you have the toolkit. I want you to think about it. What are some problems in your own life? Comparing cell phone plans, figuring out the break-even point for a side hustle? The patterns are all around us, just waiting for the right tool to come along and solve them. Hey, if this explainer helped you add some new tools to your belt, do me a favor and hit that like button and subscribe for more. And if you're ready for the next challenge, check out some of our other videos. Thanks for hanging out and happy solving.